Hello, this is Scott. Welcome back to my YouTube channel. I cover a variety of different data science, analytics, statistic topics, and so everything from open discussions to software demonstrations for different platforms. Today, I'm actually going to talk about have an open discussion because I've been wanting to do this. I've been wanting to talk about an example of Bayes' rule and without formulas. So very simple and straightforward. So what we want to look at, the likelihood of a virus given a positive test result, all right? And so if I test positive, I could have the virus, and I can also test positive and have no virus, all right? So for this particular example, let's suppose that the virus occurs at a rate of 1% in the general population. And if I have a positive test result, then the virus is present. That occurs 80% of the time. And then I test positive and I don't have the virus, a false positive in other words, and that's 10%. So true positive, false positive. Then let's do the math to calculate this likelihood of a virus. Suppose we look at 1,000 people. Right? So we look at 1,000 people, and I'm sorry, I'm doing this with a mouse. So if the virus itself at 1% of the population, then we're going to have 10 affected people. And the likelihood of a virus in its positive test, right? If I test at all 1,000, then 8 of these are going to come back positive and actually have the virus. And then without the virus, I'm going to have 990 overall, right? 1,000 minus 10. And then without the virus in the test, it's 10%. So 10% of 990 is 99. So the likelihood of the virus, so both of these are testing positive. The ones that test positive with the virus, there's 8 of those. Out of those, obviously, are testing positive and have the virus. These 99 are testing positive without the virus. And if you do the math here, this results in approximately just under 7.5%. So the likelihood that you have the virus given this test and these results is only 7.5%, which is not great. Now, there's 2 things that we can control, and there's 1 thing that we can't control. What's driving this is certainly if we want a more accurate test, we can raise this rate. Unfortunately, typically when we raise that rate, we're going to raise this rate as well, right? So the more specific the test, the more you're going to get false positives from it. The other thing that we can't control that's really driving a lot of these results is this 1%. And so this 1% is out of our control, and it's the percentage that of the population that actually have the virus. So anyway, that's it in a nutshell. That's how Bayes' rule works, and without formulas. So 8 over 107 gives us about 7.5%. Thanks, and I hope to see you again.